Hello everyone, in this video we have to see about the carbon dioxide test. We have to see previous classes about the principle of laser condition for the laser action. So it is the one of the main carbon dioxide industrial application oriented laser, that is carbon dioxide is more powerful. So it is having the producing the laser light in two different wavelengths. One is 10.6 and 9.6 micrometer wavelength region. So what is the type of the carbon dioxide laser is classified as the molecular gas lasers. So it is active medium, that is I can tell that this active medium will be the gaseous molecules of mixture of carbon dioxide, nitrogen, helium or H2O vapors, that is the water vapors will be used as active medium, and active centers is nothing but carbon dioxide. So what are the active medium will be more than that of the component, but active center is nothing but the what is the laser action produced from that carbon particular element, that is the carbon dioxide the element to producing the laser action. So what is the pumping technique? This is a pumping technique is nothing but electric discharge method technique, that is the potential differences are created between the two electrodes, that electrons with excited electron emitted from that cathode and anode, so that energy transferred to that medium, the active medium, that is a mixture of carbon dioxide molecule. Then the energy get the electrons atoms are getting the energy directly from this technique, that is the optical pumping technique. The resonator is nothing but produce the high intense and coherent light will be used for the optical resonators. So these are the three important components for the lasers. One is active medium, that is the optical pumping technique, and what is the optical resonators. So to produce the high intense and coherent beam, we will only we will get through the optical resonators. One is the optical resonators fitted with the two ends of the devices. One is partially filtered and one is fully refracted medium and partially refracted medium. So this gold mirror or silicon mirror created with the aluminum are the used for this carbon dioxide laser. Power output will be more, that is called as is about the 10 kilowatts. So it is a continuous, in the nature of output we get the continuous pulses or continuous wave or continuous laser waves we can get, or pulse we can make. So vibration, so the main production of a component, laser light production component, that is the active center is the carbon dioxide molecule. So the vibration energy state of the carbon dioxide molecule is the reason for the production of the laser light. So there is normally three types of vibration of modes will be there. Basically one is symmetric and asymmetric sketching and bending modes of the carbon dioxide molecules. So it is nothing but vibration of a carbon and oxygen molecule. So okay, symmetric means the oxygen molecule stretching horizontally horizontally is called as symmetric stretching. So it is along the molecular axis, it vibrates along the molecular axis horizontally. So asymmetric stretching is nothing but this is vibrating carbon molecule and oxygen molecule vibrating horizontally but in the opposite direction, that is called as asymmetric stretching. So another one is the bending vibrate molecule, that is molecules are vibrating vertically, that is perpendicular to the molecular axis. Molecular axis is nothing but the horizontal line will be called as a molecular axis. This is the vibrational state of the molecule. It is the reason for the getting molecules get excited to the excited state and reason for producing population immersion state. So that will be active center of and that will act as an active center to produce the active centers to produce the laser actions. So it is now. So this is the symmetric setting, that is the classification given by that different bending modes, that is the generate molecular access mode, that is the definition given by this. So this is the experimental setup that you have seen, that this is the carbon is a setup of the carbon dioxide molecules laser light. So in the container we have the mixture of carbon, nitrogen, helium will be processed through the container, and heat discharge method will be the AC/DC excitation. We have to produce the exciting the electric discharge, we giving the energy to that particular container. So first the equation test the nitrogen getting the E1, that is the energy getting from the electron emitted from the electric discharge method. So star indicate that nitrogen first get excited energy and it is transfer the energy to the carbon dioxide molecules. So then carbon dioxide will get excited, then it emits the radiation. So first in this video in this apparatus, in this carbon dioxide laser, nitrogen get the energy from directly from the electric discharge method and excited, and it is through inorganic pollution transfer, energy transfer to the carbon dioxide mode. Carbon dioxide molecule gets energy in a different energy stage and emit and get population inversion state and achieve the population inversion state through the collision. Then in the carbon dioxide molecule continuously emit the laser radiation. So this is the diagram. So you can see the wave images shows that the 100% reflector mirror, one is partial reflector mirror, only is back and forth. The laser light emitted from this process, it is moving from left and right. It will be so the light will be transferred to the left and right movement. So only left can mirror can be reflected 100% to the right hand mirror will be partially reflected to the left hand. So the light will be transferred to the back and forth motor. Once the light get coherent, the only will allow to pass through the output window. In this manner we have to get highly coherent intense light from the output of the device, that is a carbon dioxide device. So in this video I have stopped here. Next class we have to see about the another topic about the carbon dioxide and at energy level movements or mechanisms. Thank you.